Hello students, Stride here again. Today, notes for section 13.2, forces and pressures in fluid. Example to start off with. Fast moving stream of air from a blow dryer creates a column of low pressure air, and table ball is suspended in that area of low pressure. And one of the things we look at here in this section, we have a thing called Pascal's principle. According to Pascal's principle, change in pressure at any point in a fluid is transmitted equally and unchanged in all directions throughout that fluid. Simple little illustrations of Pascal's fluid. Got a 2-liter pop bottle here filled with water. It's exerting pressure on all sides of the container of that pop bottle equal at any given depth. When we squeeze it, that pressure is transmitted throughout the fluid. When we squeeze it, pressure is transmitted equally throughout the fluid. So all the pressures increase. The pressure here transmitted all throughout the fluid. So at any given depth, equal pressures act against all points on the inside of the bottle. When the bottle is squeezed, pressure still increases with depth, but it increases equally throughout the water. Hydraulic systems. Hydraulic systems based off of Pascal's principle. Hydraulic system uses a pressurized fluid acting on pistons of different sizes to change a force. And in a hydraulic system, an increased output force is produced because a constant fluid pressure is exerted on the larger area of the output piston. Such things as dump truck here uses hydraulic systems to elevate the bed. And what happens here, we put a smaller pressure on a small piston. That force is transferred to the larger piston, where it's multiplied over a bigger area, and we get a bigger output force. So small piston, small force, big piston, big force. And input force is applied to the small piston in a hydraulic system. The piston pushes against the fluid sealed within the system. Pressure produced by the small piston is transmitted throughout the fluid to the large piston. Pressure on both pistons is the same. Because the output pressure acts on a much larger area, the output force is larger. And we get the thing we call Bernoulli's principle. And according to Bernoulli's principle, as the speed of a fluid increases, the pressure within the fluid decreases. Simple little experiment you can try. If you hold a sheet of paper by its top corners, position the paper directly in front of your mouth. Blow over the top surface of the paper, the far end of the paper should lift upward. Example of Bernoulli's principle. As the air blows across the top of the paper, pressure exerted by the air decreases. The motionless air below the paper exerts a greater pressure, and that causes an upward lift. Airplanes are an example of Bernoulli's principle. Why airplanes? Birds can fly. Air traveling over the top of an airplane wing moves faster than the air passing underneath. This pressure differences gives lift. That's illustrated here. They designed the wings so that the speed under the wings, over the wings is different, generating the lift. Wings of birds, much like an airplane wing. Birds can flap their wings to produce a forward motion and some lift. Downward force on a spoiler on a race car. Same thing, only it's pushing down, giving better traction. Spray bottles, Bernoulli's principle. You may have seen some spray bottle like this connected to a garden hose. And as the water is moving through at a high speed, generating a low pressure, causes the stuff in the container to move up, mix with the water, and exit. A few quick questions. Water balloon can explode if squeezed tightly between two hands. Just prior to exploding, at what point of the balloon is the pressure exerted by the water the greatest? And it's greatest at the top of the balloon, farthest away from the ground. And that would be because the outside pressure there is smaller. A 5 Newton input force of hydraulic system corresponds to a 40 Newton output system. If the area of the small piston is 11, what's the area of the large piston? So the force has went from 5 to 40, that's times 8. So the ratio of the pistons also has to be times 8. So it would be 11 times 8, or 88 cubic centimeters. According to Bernoulli's principle, as the speed of moving fluid increases, the pressure within the fluid increases. And this is false, it decreases. So that's all we have for section 13.2. Next time we'll be at 13.3. That's all for now.